So in this video, I want to talk about, it's mostly review, but just a few new bits of information as well, the basics of all this electrostatic stuff that we're talking about. So one thing just to keep in mind in terms of the value of these forces, the electrical force is a billion times stronger than gravity. And that may seem strange because gravity seems to dominate your life, but the entirety of the Earth is pulling down on you. And it's the electrical repulsion between the electrons in your shoes and the electrons in the floor that keep you from going through the floor. Because both you and the floor are made of atoms, which are mostly empty space. So anyway, the electrical force is a billion times stronger than gravity. We already know this. There's two kinds of charges, positive and negative. They're just names. They don't mean anything beyond that. So, and we know this. We know that like charges repel, unlike charges attract, but neutral charges will be attracted to either charge as well, and that's due to polarization. Charge is this fundamental quantity in all of these phenomena. It's kind of like before when we were talking about things moving around, mass was the fundamental thing. Now, charge is the fundamental thing. What is mass? Well, it's the amount of matter in an object, right? But what truly is mass? Yeah, that gets kind of difficult as well. What is charge gets sort of difficult as well. We know this. We know that protons carry positive charge, electrons carry negative charge, neutrons have no charge, and we're not going to worry about them at all. So here's something we haven't mentioned yet. The unit of charge is something called a coulomb. So C-O-U-L-O-M-B. The symbol for coulomb is a capital C. The symbol for charge is Q, and it can be uppercase or lowercase, although it is more common to use lowercase q there. We get the word Coulomb from this guy right here, Charles Coulomb. We'll talk more about him later. He did some important experiments and wrote an important law. A French guy from the late 1700s, early 1800s. Ladies' man, looks like George Washington. So you may remember this from chemistry. A charged atom is called an ion. It's not even critical that you remember that word ion. It's just charged things are going to become important. Positive ions, remember, things that have become positive have had electrons removed. They've lost electrons. Those are called a cation, but you don't need to know that word. Negative things, negative ions, have had electrons added to them. They're called an anion, but again, you don't need to know that. The key thing here is that positive things have had electrons removed, negative things have had electrons added. And only electrons are moved. I can't stress that enough. Again, that would have been a cookie question if we had a test. Never say the protons move. Never say the positive charges move. Here's a really big thing, conservation of charge. Charge is never created or destroyed. You can't make electrons or make protons. You can move them around from place to place, but you can't create them or destroy them. That's not actually 100% true. You can't create or destroy total amount of charge. So sometimes there's things out there called a positron, which is just like an electron, but it's positive. And if a positron hits an electron, then they will destroy each other. So one positive thing gone and one negative thing gone. So the overall balance of charge in the universe has stayed the same. Sometimes a neutral or a neutron, a neutral thing, can fall apart. And when it falls apart, it becomes a proton and an electron. So it created no net charge in that falling apart. But you can't create or destroy charge. And charge always comes in chunks. That is, it is quantized. It comes in little bits. You can't have any amount you want. The smallest amount of charge you can have is the charge on an electron itself. So here's the last slide. The charge on an electron is 0.000000000. You get the idea, 16 coulombs. Or we can write it like this. E stands for the charge on an electron, and it is negative 1.6 times 10 to the negative 19th coulombs. An insanely amount of charge, which shouldn't be surprising because it's an insanely small thing. A proton has the same amount of charge, but it's positive. So a proton also has a charge of 1.6 times 10 to the negative 19 coulombs. So key things to take away from this presentation that are new is charge is measured in coulombs. The symbol for that is